Do you know how a blue whale body keeps systems working during deep ocean pressure?
Inside this vast body, many systems work together silently to keep life stable.
Organs sit in clear places so signals and fluids move without collision.
The long heart lies near lungs to shorten paths for moving oxygen.
Huge muscles wrap the frame, while nerves spread through every moving region.
Digestive spaces run behind the chest, ready to receive swallowed ocean food. Blood routes slowly form wide loops connecting gills, heart, muscles, and skin. Nerve lines map the body so each part knows when to act.
Layers of fat sit outside organs to guard them from cold water. This ordered layout prepares every system for sudden changes in ocean demands.
Inside the whale, tiny living units perform jobs that keep organs alive.
Each unit takes in food and oxygen to make useful energy daily.
Some units build muscle, while others protect, clean, or send messages inside. All units share water and salts to keep their shape steady inside. When danger rises, units change speed to save power for survival inside.
Old units break down, and new ones replace them over time, slowly.
Walls around each unit control what enters and what must leave safely.
Energy made inside units supports movement, growth, and constant repair process daily. Without these workers, organs would fail, and life would quickly stop entirely.
Signals travel through nerves and fluids to connect every working body system. Fast messages move along nerve lines to start or stop actions quickly. Slow chemical notes drift in blood to change long-term body work.
The brain sends orders that'll guide breathing, swimming, and feeding pace daily.
Sensors report touch, pressure, and sound from the wide ocean outside world.
All messages meet inside centers that decide which system needs power first.
Clear paths prevent mixed messages that could cause harmful body errors inside. This network keeps timing steady, so many systems act together smoothly, always. Receptors in skin and organs watch water pressure, light, and sound changes.
Eyes sense dim light, while ears read waves moving through water slowly.
Nose paths test water for food smells and safe breathing moments daily. Skin nerves feel cold and send warnings to inner control centers quickly. Pressure sensors tell lungs and blood how deep the body travels down. Sound signals guide movement toward food and away from loud danger sources. Light guides eye timing, so feeding happens during useful dark hours often. All these inputs merge inside the brain to build a world picture. This picture updates every moment as ocean conditions change around them constantly. Accurate sensing lets inner systems prepare before real threats arrive from outside.
Air enters lungs when the whale rises and opens its blowhole briefly.
Inside lungs, thin walls meet blood to swap oxygen and waste gases. Oxygen moves into blood, while used gases leave through breathing paths slowly.
This exchange feeds cells with air needed for making energy daily inside. Blood carries oxygen from lungs to muscles and vital organs deep inside.
During dives, lungs hold air while blood saves oxygen for later use.
Special stores in muscles keep oxygen ready when breathing stops briefly underwater.
Gas balance prevents harmful buildup that could damage sensitive inner tissues quickly.
Control centers adjust breathing speed based on activity and water depth levels. This system keeps energy flow steady during long swims and deep dives.
Blood vessels form long paths that reach every deep and outer body region.
These paths move food, oxygen, and water to working cells each moment. Waste leaves cells and enters flowing routes for safe removal later. Large tubes handle heavy flow, while tiny lines serve small tissue spaces.
Heart force pushes liquid forward in strong waves through the network.
Valves keep movement going one way without backward loss of pressure.
Flow speed changes based on need during rest, travel, or fast swimming. More flow reaches muscles during motion, and less reaches calm inner parts. Roots bend and split to cover the whale's massive body evenly.
This moving road system links all organs into one working unit. Blood acts as a moving sea that carries life inside the whale body. It holds oxygen, food pieces, salts, and many helpful control signals. Cells drop waste into this liquid so it can be taken away safely. Warmth spreads through blood to keep deep organs from cold ocean water. White cells travel inside to search for harmful invading bodies constantly. Clot parts seal broken paths when injury opens a blood channel.
The liquid stays balanced, so pressure does not harm soft inner walls.
During long dives, blood shifts toward brain and heart for safety.
Thick blood volume supports the huge size of this marine animal.
This fluid keeps every system linked and ready for sudden change. Food enters through the wide mouth when the whale opens to feed. Water and tiny animals rush inside together during slow forward swimming. Baleen plates hang from the upper jaw to block large water flow. These plates trap small food while water slips back outside again.
The tongue pushes gathered food toward the throat, opening gently.
Muscle walls guide food inward without letting seawater flood lungs. This entry step turns ocean life into usable body supply slowly. Nerve signals time mouth opening with rich food clouds ahead.
When food is scarce, mouth movements slow to save energy inside.
Proper entry control prevents damage to breathing paths and inner tissues.
Inside the stomach, strong juices break food into smaller, usable pieces slowly. Muscle waves mix food so every part meets the working juices inside.
Broken food moves into long tubes, where useful parts are taken slowly.
Walls pull sugar, fats, and proteins into blood for transport inside daily.
Leftover waste travels forward toward exit paths after value removal slowly inside.
Water returns to blood to keep volume steady and useful inside always. Good parts feed cells that make energy for swimming and growth daily. Bad parts stay separate so they do not poison organs inside ever. Digestion speed changes based on how much food enters the mouth each time. This process turns ocean life into fuel for giant body systems daily. Cells use oxygen and food to make energy needed for daily work. Small power centers inside cells release energy in slow, controlled steps. Extra energy becomes stored fat for long travel and cold protection. Sugar moves through blood to reach muscles that need fast power.
Energy use rises during swimming and falls during long resting periods.
Heat forms during energy release and warms deep organs gently inside. Control signals decide when to spend or save stored power reserves. During hunger, stored fat breaks down to keep systems running steadily.
Energy balance keeps movement possible without draining vital inner functions.
This system manages fuel so survival continues during long ocean journeys.
Bones form a strong inner frame that holds the whale body shape.
This frame protects soft organs from heavy water pressure outside constantly. Flexible joints allow bending while keeping the body long and smooth. The spine supports massive muscles used for steady forward swimming power. Ribs guard heart and lungs while allowing chest movement during breathing. Cartilage adds soft support where hard bone would cause damage inside. This structure spreads force, so no single area bears full ocean load. Support parts grow slowly to match the whale's increasing body size. Strong structure helps muscles push water without harming inner systems.
This framework keeps the giant body stable during deep ocean travel. Muscles contract in waves along the body to drive forward motion smoothly.
Tail flukes push water backward, creating force that moves the body ahead.
Strong fibers shorten and relax in timed order for steady swimming power. Nerves send quick signals that start each muscle pull at once together. Energy from cells fuels every contraction during long travel through water daily.
Large muscles near the tail create most of the forward force needed. Smaller muscles adjust fins to steer and keep balance during movement constantly.
Movement speed changes as control centers alter muscle firing rates quickly together. This motion system lets the whale chase food or escape danger safely. Force and timing combine, so huge mass moves with low effort often. Fat layers slow heat loss, so organs stay warm in cold water. Blood flow shifts to keep core parts safe during deep dives. Salt balance stays steady, so cells do not swell or shrink dangerously. Water levels adjust through waste paths to keep pressure inside normal. Breathing control keeps gas levels within safe working ranges always.
Food use changes when heat drops or effort rises suddenly.
Sensors send updates, so control centers correct small body changes quickly.
Stable inner state lets all systems work without sudden failure. This balance protects life during long exposure to harsh ocean conditions. Special glands release control fluids that travel through blood to target organs.
These fluids change growth speed, energy use, and water balance inside. Some signals act fast, while others work slowly over long time spans. Release timing depends on food levels, stress, and water temperature changes. Blood flow shifts to keep core parts safe during deep dives. Salt balance stays steady, so cells do not swell or shrink dangerously.
Water levels adjust through waste paths to keep pressure inside normal. Food us changes when heat drops or effort rises suddenly.
Stable inner state lets all systems work without subtle failure.
This balance protects life during long exposure to harsh ocean conditions.
Special glands release control fluids that travel through blood to target organs.
These fluids change growth speed, energy use, and water balance inside.
Some signals act fast, while others work slowly over long time spans.
Release timing depends on food levels, stress, and water temperature changes.
Chemical messages guide digestion, movement, and sleep cycles together smoothly.
Too much or too little signal can disturb normal inner system order. Filters in organs break down old signals after their work is done.
This keeps control steady without endless message buildup inside blood.
Balanced chemical control allows the body to adjust without sudden shock.
This system fine-tunes many actions that nerves cannot manage alone.
Skin and fat form thick outer walls that block cold and injury.
Mucus lines breathing paths to trap harmful particles before they enter.
White blood cells search for foreign bodies and break them apart. Chemical guards in blood slow the growth of invading tiny life forms.
Fever rises slightly to weaken harmful invaders inside warm blood.
Special memory cells remember past threats for faster future defense. Lymph paths drain waste and help move guard cells through tissues.
Defense actions increase during stress and fall when danger passes.
These layers protect inner systems from constant ocean threats. Sensors inside tissues notice breaks and send alerts to repair centers quickly. Blood brings building parts to damaged zones for patching and growth. Clot walls form first to seal open paths and stop fluid loss. Next, new cells grow to replace those lost during injury events.
Old, broken parts are removed so fresh tissue can take their place.
Energy use rises during repair to power rebuilding work inside. Chemical guides tell cells where to move and what shape to build. Scars form when full rebuilding cannot match the original structure. This repair system keeps the body working after harm occurs.
Control centers rank body needs when danger or effort suddenly increases quickly.
Blood and energy shift toward brain, heart, and working muscles first, always.
Less important tasks slow down to save power for survival actions inside.
Breathing and heartbeat stay steady, even when digestion pauses briefly inside body.
Nerve and chemical signals work together to choose the fastest response possible. Muscles receive extra fuel, while storage systems release saved energy quickly inside. Waste removal slows for a time to protect vital inner flow paths.
Priority rules prevent overload when many systems demand help together suddenly inside.
After danger fades, balance returns and paused tasks resume work slowly again. This coordination keeps the giant body alive during sudden ocean threats, always. Every system has limits that appear when work exceeds safe inner capacity.
Oxygen stores drop during long dives, reducing power to muscles and brain. Energy runs low when food supply cannot match constant movement demands.
Waste builds up if flow paths slow or repair cannot keep pace.
Heat loss rises when fat layers thin, or water grows colder outside.
Signal timing weakens when cells tire and lose steady control speed.
Small failures combine and threaten larger system collapse over time.
Recovery requires rest periods where strain on parts is reduced. These limits define how far survival can stretch under ocean conditions. Recovery begins when damaged systems lower effort and restore balanced internal work.
Cells adjust future behavior based on past stress and resource shortages events.
Fat stores rebuild slowly to prepare for long periods without food again.
Muscle and bone change shape to handle new movement demands in water.
Chemical signals store memory of stress to guide future responses inside body. Learning from strain helps the whales survive changing ocean conditions better daily. If recovery fails, systems weaken and life support slowly declines over time.
Survival or loss depends on how well repair meets future stress levels.